What do you think the output of these two statements? Pause the video and think about it. Now let's execute this. So we get undefined as the value of x. So here, two things to notice. The variable declaration happens at the second statement, but we are trying to access the value of x before the declaration in the first statement. We didn't get an error, but we didn't get the value 5 as well. We get undefined. Why this behavior? This is happening due to something known as hoisting in JavaScript. Okay, what is hoisting? Hoisting is basically allocating memory to all the variables and functions before its actual execution happens. We might have heard that it's basically moving the variable declaration and function declaration to the top of the file, then executing. So if you take these two statements, it behaves like, let me comment these two. It behaves like first it moves the declaration to the top, which means var x, then the execution. So the behavior is similar. So if you consider these two statements and when we execute it, we get the value undefined here, and in the second statement we assigned the value 5 to the variable x. If you look at here, from this initialization we moved the declaration to the top. So at this statement we have declared a variable x, and what will be the value of the variable x? It will be undefined. Now we are accessing it in the second statement and we will get undefined, and after this statement we are assigning a value of 5. So this is why in some places we may see hoisting as moving the declaration to the top of the file, but that is not actually true. Now if you take these two statements, there is two phases of execution. The first phase is the create phase, where all the variables and functions are registered along with its memory allocation. So basically memory allocation. And the next phase is execution phase. Okay, what happens here? Runs the code line by line. Okay, now see this. We have two statements here. We are trying to execute this. So first what happens? The create phase. We need to allocate the memory. So here, this is a variable declared using the var keyword. So memory allocation means allocating memory to the variable x. And here, along with allocating the memory, it actually gives an initial value. So in this case, the initial value is undefined. So that happens first. That's the create phase. After that, the execution phase happens. So it goes to the first line. Since the memory is already allocated and its initial value is undefined, we will get undefined here. Then the undefined is replaced by the value 5. Okay. Now let's change this with a let variable. Okay. So this time from var, I'm using the let keyword and see the output. Now an error is thrown. What is the error? This is a reference error, and the error says cannot access x before initialization. So here the initialization happens at the line number 2 and we are trying to access the value of x at line number 1. So we are trying to access before its initialization or declaration. So due to this, when we use let or const, due to this, we sometimes say let and const variables are not hoisted like var. So what does that mean? Not hoisted. So hoisting just means to allocate the memory. So if that's the meaning, what happens with the let and const? Do we or don't we allocate the memory before the actual execution happens? No, that's not the case. All kind of variables are hoisted in JavaScript, even let and const. But there is a small difference. When we explain the case of var variable, along with its memory allocation, we gave an initial value which is undefined. But the case of let and const variable, the memory allocation happens here too before the execution happens, but we don't give an initial value. So we only allocate the memory and the initial value happens only at the initialization or declaration phase. Okay. So here in this case, when we try to access the value x in this line, actually the memory is allocated for the variable x, but there is no value. So that phase is known as, or that area inside the scope of that variable is known as temporal dead zone. So let and const variable, before its declaration, it's in temporal dead zone. Okay, so we are trying to access the variable which is in temporal dead zone. That's why we are getting the reference error. Okay, so just like var variable, let and const variables are also hoisted. I can prove this by an example. So here, x is a global variable declared using the const keyword, and I have created a block, and inside the block I am trying to access the value of x. Since x is a global variable, we can easily access the value x inside this block. Now I'm going to save it. No issues. We get the value 5. Okay. Consider that const and let variables are not hoisted. And now I'm adding a new line. Okay. So consider that const variables are not hoisted. So in this case, let's see what's the result. We get cannot access x before initialization. Okay, so we get the error from here. It says that we are trying to access the variable x before its initialization. Now, when we consider const variables are not hoisted, we shouldn't get this error because we already have a variable x outside, and when we get to the line number 3, it should print 5 since we already have a global variable x. But what happens? So const variables are block scoped. Okay. Now these are two different variables. This is a local variable. The scope starts from here to here. But this is a global variable. The scope is everywhere. So when the JavaScript runtime gets to the line number 3, it knows that there is already a variable declared in this scope with the same name. How it knows? Because of hoisting, which means before executing this first line, the hoisting of this variable is already happened, which means memory is allocated, but there is no initial value, which means in this line or from the scope starts from this to this line, x is in temporal dead zone. So we are accessing a variable in temporal dead zone. That's why we are getting an error. So from this example, it is proved that const variable and let variable are also hoisted. Okay. Now let's take the case of functions. Let's create a function first. So I have created a single function or simple function with the name print name, which receives a name and which logs it. Okay. Now first we can try to access the value of the function. So here we are only accessing the value. We are not using the function. So the function declaration happens at line number 3 and we are trying to access it from line number 1. You can see that we didn't get undefined or any error. We get the full value of the function. So that is the difference between variable hosting and function declaration hoisting. When it comes to function declaration, along with the memory allocation, the full value of the function is also given. Due to that, not only we can access, we can actually use the function before its declaration. So let's try it. Okay, we already have the log, so we don't need a console.log. So we get John. So there is no issue because functions are hoisted with the full value, so we can actually use it before its declaration. What happens when it is function expression? Okay, so let's change this to a function expression. We can use a var variable. Now we don't need a name here. We can give it, but we don't need it. So this can be an anonymous function. Now the reference of the function is saved to this variable. Now this is a function expression. Now we are trying to access the value of this variable undefined. So there is nothing new here. We changed the declaration to an expression that now depends on the type of the variable. Now the variable here created using the var keyword, and what happens if you try to access the value of the var keyword variable before its declaration? Its value is undefined, which means the memory allocation happens with the initial value undefined. Since its value is undefined at this stage, what happens if you try to execute it? We will get a different error. Print name is not a function. Why? Print name is undefined at this stage and we are trying to invoke it and we will get the error. It is not a function. Okay. Now what happens if we change this var to const? So it's the same behavior for the const variable. If you try to access it, we will get a reference error because in this case now print name is in temporal dead zone. So we'll get the reference error. Cannot access print name before initialization. Okay. So that's the case with function hoisting. Now the next thing is with ES6 classes. So let's create a simple class. So here is a simple class person which gets first name and last name and which creates two fields and store the first name in the first name field and the last name in the last name field. Now let's try to access the value of the person class first. Okay, so we declared the class at line number 3 and we are trying to access the value. We are not using it, or we are not using it to create an instance. We are just trying to see its value. Now we get the reference error. Cannot access person before initialization. So this is the same behavior with a let and const. So if you create a class, the memory allocation happens before its execution, but there is no initial value, which means if you try to access it before execution, before declaration, it will be in the temporal dead zone, so you'll get a reference error. Okay. Now there is another way of creating classes. This is a class declaration. Just like functions, there is also class expressions. So how it will be? So for our person, now we can give the reference to this. Now we don't need this name here. Okay. Now this is a class expression. So a class is created at the right side of the assignment operator, and its reference is saved to the variable person. Now the behavior is just like variable hoisting. It depends on what type of variable. This here is a var. So what will be the value? Undefined. Since it's undefined, if you try to use it, which means if you try to create an instance using this person class before its declaration, it throws an error because at this phase, person is undefined. Okay, so that's uh, the behavior with class expression. Now, what happens? So let's consider this. We are using ES5, not ES6, so we don't have any class syntax. In that case, we have to create the same behavior using function constructor. So let's try that. Let me comment this and create the same behavior using functions. Now this is a simple function constructor which gets first name and last name, and it creates a field first name and stores the value first name, and creates a field last name and stores the value last name. First, we will try to access the value. So you can expect, because this is a normal JavaScript function. So functions are hoisted with full value. So we will get the full definition here. The only difference is that this is not a normal function. This is a function constructor. Due to that, we can use the new keyword to create an instance with this function. So since we have the full value, let's try to use it. So here, since we have the full value, I'm using the new keyword to create an instance using this function constructor and passing John as the first name and Doe as the last name. So we don't get any error. We just created the instance and we logged. So you can see that first name is John, last name is Doe. Okay. Now we have covered variable hoisting, function hoisting, and class hoisting. And the last thing to look is the ES6 import export statements. So here I have two files. Okay. So from hoisting 2, I'm exporting a const variable. Okay. Now I'm importing the variable a from this file. So I'm exporting variable a, which is having a value 5, and I'm importing that variable in this file, and let me log it. So you get 5, value of 8. Now let's move this after this. Okay, so this here, I'm accessing the imported variable in line number 1, and the actual import statement is at line number 2. Okay, still we don't get any error, we get the value this. Why? Import statement is also hoisted, which means allocating the memory and the full value happens first before the actual execution happens. It doesn't depend on the variable type or anything. Okay, so here you can see that we are exporting a const variable. It doesn't matter. So here the syntax, the import statement is taken care of it, which means before the actual execution happens, the memory for A is allocated with its actual value. Then the actual execution happens and we get the full value. So we have covered hoisting of variables, functions, classes, and import statements. So things to note here is that hoisting is not just moving the declaration statements to the top of the file or to the top of the scope. It's allocating the memory, and depending on the variable type and functions, the behavior is a little bit different. Sometimes we get an initial value of as undefined, sometimes we don't give an initial value, and sometimes full value is initialized during the memory allocation. Okay, so that's the difference. But every kind of variables and functions are hoisted. One thing I missed is case of arrow functions. So it's also similar. So you can see that arrow functions are also always function expressions. So that is also depending on the type of the variable that we are using to create the function expression. Okay, so that is hoisting. I hope you have understood and hoping that you liked this video. Thank you for watching.